And yes, I need to run a little bit. I need to run really fast. And you know who I am? Right now, I'm representing all the students who are preparing and who are facing difficulty with physics. And you know who is behind me? That's the physics dinosaur. And it's going to eat you up. And the only way to escape the dinosaur is basically to, okay, I'm tired. Let me stop running. Let's learn how to control it. And let's get this physics under control in this Zero to Superhero series. With me, Shreyas, your physics master teacher. Okay, so guys, let's stop running away from physics. Let's stop, avoiding the difficult parts. Let's embrace it. Let's face it, because you are going to ace it. And you're going to ace it with your physics master teacher. My name is Shreyas, and I'm going to be your mentor, your guide, your navigator, your captain on this ship called JEE ENLITE. So join in. This is now a very unique channel, one of its kind for all the JEE and the NEET aspirants. So welcome aboard to We Enthuse. And if you have not yet subscribed and liked the video, come on, go ahead and join it. Hello, Blessy, Yuva, Dinesh, Jermia, Saranya, Navili. Welcome, Minu, Tamil. Hello, Anjana. Hello, everyone. Yep. Oh, definitely, Anjana. I will take up basic maths also sometime. Definitely before the exam, for sure. It's so nice to see all the students together. And finally, the day comes when I don't have to say, yes, this is for NEET 2. Yes, this is for JEE 2. So guys, on high demand, and because you guys wanted this channel to work both for JEE and NEET, there we go. And here is your super duper hero series. And today's lecture, we are going to do wave optics, the conceptual part, the formula part. It's a one shot. Tomorrow at 5:30, what time? Come on, put it up in the chat box so that everybody seeing the chat box knows, okay, something is happening at 5:30 on Tuesday. You're going to have problem solving. But today's questions will be very easy, but it will be so much fun because you're going to participate in a quiz. You're going to participate in a quiz. Exactly. And in today's class, I will teach you the entire chapter so that after today's class, when you open NCERT or HC Verma and start solving problems, you see a lot of familiar terms. You do not feel lost. And after tomorrow's class, that's it. You will become a superhero. Okay, with me? So all these topics covered today. And thank you so much for all the lovely hearts. Oh my God, I can see the screen filled with hearts. It means a lot. Keep this Josh high till the end of the class. And thank you for liking and thank you for subscribing. Hi Naveen, hi Harni, hi Kavya. Let's begin. Okay, so I can already see you guys are excited. I don't even have to ask you, are you guys excited? And that's the way it has to be. Hello Hema, hello, thank you so much. Okay, let's begin. So what is oh by the way, I will be giving you my handwritten notes of today's class. So whatever I write over here, okay, whatever I write over here, it will be available as PDF. Make sure you join the Telegram channel. The link is there in the description box. So you just have to download it. Don't worry so much about making notes now. If you feel something is important, what I say, but it is not written down, okay, feel free to write. But otherwise, you're going to get the entire notes in the form of PDF after the class. Okay, by tomorrow you will definitely get it. So let's talk about light waves. And before we start light waves, what is a wave? What is a source? Let's talk about it. So I'm just going to put up the definitions. I'm going to write it out as well. So see, what is a source? A source of light. Look at this diagram. It is very much self-explanatory, but still there is this liquid. You are poking it. You are disturbing it. So source is nothing but disturbance. It's a disturbance which is created. It's a disturbance. And what happens to the disturbance? It propagates. It propagates like you are in a class. Some kid, notorious kid will be there. Hey, listen to this joke. Then that kid will tell that joke to others. He will pass on the disturbance. Everybody is starting to laugh in the class. Everybody starts making some noise. Correct? So that disturbance propagates. So that disturbance propagates. And that phenomena is called as waves. That phenomena where the disturbance propagates. What actually propagates is nothing but the energy. So it spreads in all the directions, and here you have two terms like ray, you have a ray, and you have something called as the wavefront. So any kind of wave will have rays and wavefronts. So what is a ray and what is a wavefront? So when you are talking about ray, it tells you the direction of propagation. It tells you the direction of propagation. So for example, this is the direction in which the ray is propagating, and the wavefront. What's the meaning of a wavefront? It's basically all the points which have the same phase, or where the disturbance reaches at that point simultaneously. For example, I'm a very bad student. I'm making some noise, I'm cracking some jokes in the class. I tell that joke starts spreading. Right now, the joke has spread. It has reached some 5-6 students here, there. So all the students where the joke has now reached, that is your wavefront. Everybody with me understanding this? Yes, 2023 also can watch this. 2 sessions, Bala Murugan, first session, theory concepts with basic questions, second session with problems only. Yep, is that clear? So all points where the disturbance reaches simultaneously. Sometimes it is often technically written down as basically they are in the same phase. Keep this in mind. Okay, so if this is the way in which the ray is propagating, your wavefronts will be something like this. The blue ones are your wavefront. The green one is the direction in which the rays are moving. The wavefronts start moving in the direction of the rays. Everybody with me? Very good. Yes. Varun, is it available on YouTube? I'm not sure what you are saying, but yes, whatever I'm going to teach here, it will be there in the recorded form on YouTube. Yep. And the PDF will be available in Telegram. Next point, going quickly. So now that we have spoken about wavefronts and rays, we have to slowly move to Huygens principle. And like I have told you, wavefronts is the locus of particles having same phase. I just put it up in the notes, but this is the printed form. Don't get scared. Direction of propagation is perpendicular to the wavefront. We have seen that over here. Wavefront is this one, the blue one, and it is perpendicular to the direction in which the rays move. Okay. The speed with which the wavefront moves outwards from the source is called as the speed of the wave. Makes sense, because the wavefront will start moving like this. The speed at which the wavefront moves is your speed of the wave. Each wave has a speed, and that speed depends completely on the medium. So very, very important. The speed of the wave completely depends on the medium. So C is equal to F into lambda. This frequency depends completely on the source. Many students get confused when the questions are asked, what will happen when wavelength is doubled? When lambda is doubled, will frequency be doubled? Or speed of light is doubled? Guys, understand, you cannot double the wavelength, okay, because wavelength depends on frequency and speed of wave. Speed of wave depends on the medium. When you change the medium, that's when the wavelength will change. Or when you use a different light bulb, frequency will change, hence wavelength changes. Wavelength comes in the end. Wavelength cannot be changed unless you change frequency or the medium. Everybody with me? Understood this point? Yep. Notes will not be available in YouTube, bacha. The notes will be seen on the screen, but in PDF, obviously it will come only on Telegram. Thank you so much, Chikivaram Bhartam. All right, great. Keep this in mind. Very, very important flow chart. Medium decides speed. Frequency decided by source. Lambda, I'll put it up over here for you. Wavelength decided. It's decided by frequency and the speed. Keep this in mind. All right. Now there are 3 different kinds of sources. Okay, don't worry guys, even if it is overlapping, when you get the PDF, I'm going to change this. I'm going to move this little bit up and on the side so that the notes will be visible to you. Depending on that, you have different kinds of wavefronts possible. Like, you have seen a JBL speaker, something like this. I don't know. Wait, let me just show this to you. Okay, I have this beautiful JBL speaker and it emits sounds in all the direction. So this is like a cylindrical source. It creates wavefronts which are cylindrical in nature. So this is a cylindrical source. Or your tube light, it emits lights in all the directions in the form of a cylinder. So that's a cylindrical source. A point source like a bulb, a small point, and it emits wavefronts here, 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 here. That is your spherical source. Okay? And sometimes you would have seen things like this. You would have seen things like this. Oh, by the way, this is my studio light. This is like a planar source. It creates wavefronts which are moving in a plane form. They are moving parallelly. That is your planar wavefront. Everybody with me? Let me know in the chat box. So 3 kinds of wavefronts possible: planar wavefront, cylindrical wavefront, spherical wavefront like from a bulb. Amazing. Now, what does Huygens principle say? Okay, Telegram, don't worry, I will modify the link towards the end and I'll help you out. Don't worry guys, I will change it. Huygens principle says that you can figure out what is the new wavefront going to look like after some time using the principle. And the principle is that whenever wavefronts move, they indirectly create new sources called as secondary sources. So a source creates wavefront, it moves, the wavefronts are the disturbances, they move, and those disturbances basically ignite and create new wavefronts or new sources. Those sources create new wavefronts. Those new wavefronts create new sources create newer wavefronts, and that's how the wave propagates. So light is a wave, that's what he says, and it propagates in space, much like the ripples of water. So when you drop a stone, there are ripples on the water, and those ripples disturb the next and the next particles of water. Something like that, that's what he said. And the light spreads out like a wave along all the directions from the source. So source creates the disturbance. That disturbance reaches everywhere on the blue line. The blue line is going to ignite and create new sources, the red dots. The red dots are secondary sources. I will put it up over here. These are your secondary. These are your secondary sources, and indirectly you are going to get secondary wavefronts. Secondary wavefronts. Very, very important. And what is this? This S over here, this is your primary source. This is your primary source, the one that you see over here. Now, how does this help you to find out what is the new wavefront going to look like? Well, that's called as the Huygens construction. See, Huygens construction says that when you have to find out where is the new wavefront, all you need to do is draw circles, basically secondary wavefronts whose radius is speed into time, speed of light into the time after which you want to find the new wavefront. When you draw all the new circles, the new wavefronts, you can draw a common tangent. The common tangent gives you the new wavefront after some time. So, if you know the shape of the wavefront at t is equal to 0, then the Huygens principle tells me how to find the shape of the wavefront after some time. Yes, addiction, even 2023 students can watch. Yes, the secondary wavefronts won't interfere with the other wavefronts. The secondary wavefronts interfere with each other to create a resultant wavefront. So the new wavefront that you get is the superposition of all the wavefronts. That's what it is, Jermilia. So look at this. This was your initial wavefront. I can call this as your primary. This was your primary wavefront. Then what you do is you draw secondary wavefronts. These are your secondary wavefronts whose radius, what is the radius? The radius will be equal to speed of light into the time for which you are waiting to draw the new wavefront. This then, the common tangent that you see over here, the common tangent, this is your common tangent. This common tangent gives you basically the new wavefront. This is going to give you the new wavefront. Yep. When will it be in a straight line, Siswa? This can happen when you have a planar wavefront, something like this, bacha. This is going to create plane wavefronts, straight wavefronts. So, you know, this is going to create plane wavefronts, or when you're very far away, then the wavefronts almost lose its curvature and they almost become flat. That's when it is going to happen. Okay, Siswa, I hope that is clear. Look at this. This is a circular wavefront. You again draw the secondary wavefronts, and each one has a radius of velocity into time. Velocity into time. Speed into time gives you the distance which it has moved. Distance is speed into time. You draw the common tangent, you again get the new wavefront. So what is the way of drawing or finding the new wavefront using Huygens principle or Huygens construction? Always start by the primary source, draw the wavefront, and draw circles whose radius is speed into time, speed into time, speed into time. Draw a common tangent. That common tangent gives you the new wavefront. Okay. Is there any case where the wavefront is non-uniform? Definitely possible, bacha. Something like this. Let's say, for example, you have a source which is itself like this. Each of them will create secondary sources like this. These are your secondary sources. And then I will have secondary wavefront something like this. These are your secondary wavefronts. Each circle that I am drawing has a radius of c into t. Okay, like this. Now draw a common tangent. Draw a common tangent to all of them. This will become your new wavefront. Okay, yes, that is also possible. Jagdish, we enthusiast now, we enlight. Looks like you have been living under a rock. Yep, a lot of things have happened on the channel. Please watch the past videos, bacha. Can two wavefronts cross each other? Yes, and that's what we are going to talk about in a bit, which is called as interference. It is called as interference. Okay, great. So we have just shown you how to find out the shape. I think now it should be time for a quiz, but before that, let me also show you how reflection and refraction is explained using Huygens principle. Look at this. Primary wavefronts coming, hitting the surface, and this is a reflector, this is a mirror. Each point on the mirror acts like a new sources, secondary sources. Each secondary source creates secondary reflected wavefront. Usually the wavefronts would have gone like this, but it's a reflector, so the new secondary wavefronts are formed over here. That's why you will see that the wavefronts, because this reaches here first, then this reaches, then this reaches. So you will see that this will be the source which will be ignited, which will be started at the end. This will be the source which would be started at the first go, because the wavefronts reach here first, and you will see that the reflected wave goes over here. The reflected wave goes over here. Okay, because this point will be creating a big wavefront, this point will be creating smaller and smaller and smaller, because these points take a lot of time to reach, and by the time they create a wavefront, this wavefront will be small. Okay, same way refraction. Look at this. Look at this. This is a wavefront which is going through air or a rare medium. This wavefronts reach here. They start creating secondary wavefronts at all the points in some denser medium. But remember, in the denser medium, the speed with which it expands will be less. So you will see that as soon as these wavefronts reach here, the circle which is formed here will be smaller. It will not be at the same speed, because this is air or rare medium. It will be propagating fast here. It will be expanding little bit slowly in the denser medium. That's why you will see that the wavefront bends, because the wavefront size will be small here, and that's why it ends up bending. You can see that. That's why you can see that. Okay? No, Jagdish, you should not leave optics for JEE. Okay, I think now it's time for a quiz. I've also put up advantages and disadvantages. You should know this for boards. For boards perspective, you should definitely know it, and it can be asked in probably something like a very factual or easy based questions in NEET or in JEE mains or in CET. But otherwise, okay, understand, it will not come like a problem. It will be just like a fact based, but more importantly, for boards, you need to know the advantages and disadvantages. Thank you, Google Achu. Wanna come? All right. So get ready. Namaste Jai. Welcome. Thank you, Prakash. And here comes your quiz. How to join the quiz? There is a link on the chat box. Number 2, if you are on the Telegram channel, the link is also pasted there. Number 3, if you can't find the chat box, guys, in the description box also there is a link. 3 ways, or 4th way, go to vquiz.com and enter the 6-digit code. What is the 6-digit code? 224173. 224173. Okay, all right. So Chandralekha, in refraction, bacha, what happens? I'll just show you over here. See, I'll just show you over here. This point will create a smaller wavefront, big and not as big as this. This point, by the time it reaches here, this circle, this wavefront would have grown bigger. This will now start creating wavefront. When this point reaches here, okay, then it will create a wavefront, but by that time this would have grown bigger. This wavefront would have grown even bigger, and when you draw the common tangent, you get the new wavefront. But it will not be parallel because the rate at which the size increases is less. In air it expands more, in water or glass it will expand less, hence it will bend. Hence you will see the bending of light or refraction phenomena. So refraction is, that's how it has been explained using Huygens. Okay, so the code, like I have told you, it is nothing but, I'll just put it up over here. It is, okay, it is 224, it is 224173, 173. Okay, come on guys, join in. I'm opening up the week quiz right now. Okay, yes, it is there. Oops, is there a way I can just escape and let's say present? Okay, there we go. Let's go to joining screen, and we have people joined in over here. Great, come on guys, join in. I think everybody is good to go. Everybody is good to go. I'm starting the quiz in less than half a minute. Get up, my warriors. We are going to have quiz theory. Quiz theory. Isn't it going to be fun then? Yep. Let's start with the quiz. Okay, come on, everybody join in. Make sure your names are put up properly, and make sure that your attention is on your screen where the quiz is running, because my video might come after some time, but the quiz will start immediately as soon as I start over here. Okay, chalo, let's start the quiz then. Get up, and starting the first question coming up on your screen now. There you go. Get ready. Okay, so oops, my bad. Guys, hold on. This is not supposed to happen. Okay, 1 second. This was not supposed to happen. Why is this quiz here? Okay, this quiz was not supposed to be here. I'm so sorry guys. There is some rearrangement problem. Just 1 second. Just 1 second. This was not supposed to happen. Okay, just 1 second guys. Okay, I'm so sorry, this was not supposed to happen. This quiz was supposed to come towards the end. I'm not sure why it has come right now. Okay, anyways, I think there is no point playing the quiz if it's showing some random quiz right now. Anyways, we'll just play it over here guys. I'm so sorry, let's play it over here. This was the quiz supposed to be on the screen. In Huygens principle, the relation between wavefront and the ray of light is, come on guys, answer. The quiz has come, but the quiz which has come is not correct. The quiz which has come is not correct. That's the problem. Okay, just 1 second guys. Okay, ignore guys. I mean, this was not supposed to happen. I'm so sorry. Yep. Okay, let's start with the first question on the screen. Let's play it on the chat box. I will get it rectified. Maybe the order of the questions was slightly different in the week quiz. I'm so sorry. I apologize for that. So, a ray of light, obviously, yes, it is perpendicular. Thank God, you guys are correct. And yes, I just told you about this, that whenever you have a ray of light and your wavefront, the ray goes like this and the wavefront is always perpendicular to it. Proud of you. Next question on your screen. A spherical wavefront as shown in the figure strike a plane mirror. Look at this. Spherical wavefront strike a plane mirror. How do you think the wavefront will look like after? What's the shape after the reflection? Come on. Is it A? Is it B? Is it C? Is it D? Come on. Sir, do I need to watch the replay of the classes if I join today in the JEE crash course? No, Aslam, you don't have to. I mean, even if you miss something, then you can watch the replay. But I think Monday is the first day of the crash course, so I don't think you need to. Okay, many students are confused between C and somebody is also saying B and somebody is also saying D. Well. Look at the rays, then everything will be clear. If you look at the rays of light are coming like this. It is coming like this, correct? So after reflection, what will happen? Obviously, after reflection, it will go like this and like this. So observe the rays and draw the perpendicular, because wavefronts are always perpendicular to the rays. It should look somewhat like that, and I think only C option is there like that. Yes, it is option C. How can it be this or this? How can the rays come from here and go there? How is that reflection? How can this or this be true? If it is spherical, it will remain spherical, guys. Just draw the rays, it will become very, very obvious. Got it? Okay, amazing. So concept problems. Now, this next concept most students ignore, or generally it is not taught in your coaching or maybe skipped in the school. So this is Doppler effect in light. There have been instances of these questions sometimes in some CETs, in some competitive exams. Not very important, but if you get, you do not want to leave it. So, do you remember Doppler effect in sound? When there is a relative motion between source and the listener, there is a change in the frequency. Same way, whenever a light source moves, then the frequency, the color which is perceived is different. So that is called as Doppler effect of light. In fact, Doppler effect of light is used to figure out whether some distant star is moving away from you or whether it is coming close to you. That is something called as the red shift and blue shift. Let's not get there, but remember, whenever something moves away, the color will be different. Whenever something comes close, then it will be different. Then you will be like, sir, this is enlightenment. On Enlight channel, you are enlightening us. This is very cool, sir. So if I am wearing a yellow shirt and if I start running towards my friend, will I appear blue or will I appear red, sir? Sorry, that will not change, because who can tell me the reason? Who can tell me? Oh, a lot of you are already saying, sir, skipped in the school. So bad, guys. It's not supposed to be skipped. Okay. So why will your friend wearing a yellow t-shirt running towards you, the yellow t-shirt will not change to blue or red? Reason? Hi Sonalika. Yes, the speed with which the source or the observer moves is very, very less as compared to the speed of light. Yes. So only when the speeds are comparable, that's when you see a significant change. That means your friend should move with kilometers per second or hundreds of kilometers per second. Then you will see some change, or else you will not see the change. Yes. So, yep, your friend for sure, he cannot reach speed of light unless he is some god-like particle. Okay, bachalo. So, you can see stars moving away or moving closer, their frequency changes and you will see a different color. The same thing. Generally, these stars move with very high speeds, lakhs of kilometers, per second. So that's the reason for that. Now the change in the frequency formula is given by this. Now if you are getting confused with the symbols, it's okay. I will give you the better one. change in the frequency upon the original frequency is equal to negative v, or the speed of the object which is being moving, or the source, upon the speed of light. This c is obviously your speed of light. This is your speed of light. Now this v, you need to be very careful. How should you put the sign? Very, very careful. Observe this carefully. When you are moving away, radial, it is also called as the radial speed. What is radius? Radius, everybody knows, right? If you have a circle, this is radius. If this is source, this is observer, or whatever, this is source, this is observer, you are going away, the radius is increasing. If you are going away, the radius is increasing, this v is positive. If you are getting close, then this is negative. Radius, radial, position. So if the vector increases, positive. If the vector decreases, then this v is negative, and there is already one negative sign outside. Keep that in mind. Okay? Yes, Jernia, it's outwards, bacha. Okay? Great. Amazing. So let's see if we can solve a question. Get ready, gear up. Everybody with me? Hi Nandini, welcome aboard. What if the man can't move with the speed of light? I feel sorry, but you will see him of his original color only, Trivikaran Bhartam. Okay? You will not see much change. This will only happen for very high speeds. I'm not sure if the quiz is running, guys, so I don't want to take a risk. I'm so sorry. I will try to make things right by the next lecture. Okay? Okay, so here is the question coming up on your screen. The spectrum of a star is shifting towards violet color, then the star is going away, coming towards. Intensity is increasing, intensity is decreasing. What do you guys say? Spectrum of a star is shifting towards violet color, then what do you think about it? All right, come on. Somebody is saying option A, somebody is saying option B. Is going to get confusing. All right. Okay, it's coming, says King. Diljan saying B, Saranya saying C, Priyadarshini saying B, Yuvashri saying B, Siddharth saying B. Edna Siddharth, Anga in Iruka. What happened? Okay. So, guys, the correct answer is option B. It's coming towards the earth. Let's understand what has just happened. See, the spectrum is shifting from towards violet. If you're talking about violet color or blue colors, then the wavelength is basically getting smaller. If wavelength is getting smaller, then the frequency is getting larger. It's getting larger. Now, if you look at the formula which I just gave you, del F by original frequency minus V by C, it's obvious is F is getting larger. That means this term over here is basically positive. This term over here is becoming positive. Change in the frequency, it's increasing, so positive. Hence, since there is negative term over here and this RHS should also be positive, that means V should be negative. Velocity should be negative. Why negative? Because negative into negative, positive. If LHS is positive, RHS is positive. If this is negative, V should be negative. And what did I tell you about minus sign? Minus means coming close by. So hence, it is coming close to the earth. Okay, cool. Understood? Which color have minimum refractive index? Yes, Dhanya, I'll tell you very easy way. Do you guys get confused which color has more wavelength, which color has less wavelength? I'll tell you, simple fact. Remember prism? Okay, when you have white light going in, okay, remember Vibgyor, violet, indigo, blue, green, yellow, orange, red. So here you will have violet, indigo, blue, and then you have green, and you have yellow and orange and red. This is something which you should know. Red has very large wavelength, and then yellows have, little bit decent wavelength, smaller, and as you go towards blue or indigo, the wavelength becomes smaller, and when you go towards violet, it is even smaller. And like you can see, violet deviates the most, so highest refractive index. Red deviates the least, so it has least refractive index. Got it? Everybody clear? Understood? Thank you very much. Yes, important topics, but all concepts are new. All the concepts, all the topics, subtopics I am going to cover. Okay, so that's why you have this phenomena called as blue shift and red shift. Blue or violet is making the wavelength smaller. Red means making the wavelength larger. So if a star is coming towards you, it is blue shift. If it is going away from you, then it will be red. If you see a red star in the sky, that means you should think most likely it is going away. And if you see a violet or bluish star, then you should think, oh, the star is coming towards me. Understood? So next time you look up in the sky, you know what it means. Let's move on to the next concept, coherent, incoherent sources and interference. So coherent means in sync. Like for example, I remember those days in school, you know, where we used to sing a song. Yeah, we used to sing songs and we used to be in sync. Like, I don't know, maybe Jana Gana Mana or maybe something, some nice songs. Okay. And you know, sometimes there are these students who are completely out of sync. So, the teacher is singing some song, okay, like whatever is your favorite, and then this student is completely out of sync, saying his own version in some other tune. That is incoherent. You're not in sync. When you are in sync, that is coherent. So when you have a source, it is creating many waves. Everywhere it is creating waves. If all these waves are in sync with each other, and you know the relationship between them, that yes, if this wave is creating a crest and this wave has a trough, I know that when this creates a trough, this has a crest. So there is a direct relationship between all the waves. Then it is said to be coherent. When there is a relationship which is always obeyed. But if there is no relationship and you see that they are going haphazardly, then it is incoherent. So I have a question for you. This light over here, my God, I look so fair. So yeah, this is like, I don't even need those creams which they sell in the advertisements after this. So guys, is this light coherent? Oh my God, there was an ant over here and there is a mosquito. Okay, I'm just removing it. Okay, sorry guys. All right. So is this light coherent or incoherent? And guys, it will be crazy, right? If I turn off all the lights and just turn on this light, I will look like a ghost. Okay? Sorry guys, I can't do that because if I turn off the lights, then my computer will turn off and the stream will end. So sorry. Some other time. I will scare you some other time, not today. Okay, it is incoherent. Why is it incoherent? You'll be like, sir, it's white, sir, everywhere white. No! This wavelength is something, this wavelength is something, this wavelength is something. So all the sources around you are generally incoherent, guys. They are incoherent. Yes, to create coherence, you need some dependency. To create sync, you need some dependency, some relationship like this. Wavelengths or wavefronts are coming from here and they are simultaneously reaching these two slits. They are simultaneously reaching these two slits. These slits create new wavefronts. These two sources are coherent in nature. These two sources are also said to be, derived sources. Derived sources are always coherent. Remember that. Because they are derived from the same source, they get lightened up together, and whatever wavefronts come out of it, they are always coherent in nature. They are in sync with each other. Now, you basically study interference of light for coherent sources. Meaning, Shaurya, I'm so sorry the code is not working because the quiz just got messed up. I apologize for that. Hi Nidhi, welcome. Okay, so That's why, Rahul, study from me. You don't have to study line by line. Line by line NCERT does not work for physics. That works for bio, but not for physics. For physics, it's concepts, formulas, application, problems. That's all you need to do. Fair enough. Now, you are speaking. Your friend is speaking. There is music in the background. Your mom is screaming at you. Your sister or brother is throwing chappals at you, or he's pulling your hair and screaming his lungs out. So then everybody is talking in the room, but you hear everything because all the sounds are interfering. It is true with all the waves, be it light waves, be it waves on water, be it sound waves, be it waves on string. All waves interfere and they produce a resultant sound. Correct? And for understanding what kind of interference is there, we define few terms here, starting with path difference. Path difference. You and your friend start together. You and your friend start together. And you have to reach some place. Let's say this is, okay, we have Pandu over here. Okay, this is Pandu. And here we have Andu. Okay, this is Andu. And they have to meet Champa. They have to meet, whom they have to meet? This is beautiful, Champa, guys. Now they both start together. Pandu reaches Champa. Andu also reaches Champa. But who will reach Champa first? Who will reach Champa first? Come on, guys, both have the same speed. Both have the same speed. Who will reach Champa first? Obviously, Pandu will reach Champa first. Yes, Pandu will reach Champa first. Correcto? Understoodo? Clearo? Now tell me, guys, when Pandu reaches Champa, Andu is still on the way and he is shocked. Oh my God, Pandu reached Champa. He is going to get her. I am late by this much distance. That distance is called as the path difference. That difference is called as the path difference, guys. So, whenever you have two sources and they interfere, one of the light is lagging behind before they interfere and they meet the Champa. So, that difference is called as the path difference. That path difference creates a phase difference. You'll be like, sir, what is phase, sir? What is this phase? Explain me. Hold on, coming to that. See, first of all, understand this. When you have a wave, then two points separated by one wavelength, point 1 and point 2, they go up and come down, together. That's 2 points separated by one wavelength. They always go up and come down, together. They are in phase. 1 and 2 basically have a phase difference of 2 pi radian. Phase difference. They have a 2 pi radians, 360 degrees. You start and come back to the same point. Basically, they are in sync. So they have a phase difference of 2 pi radians. Clear till this point? But if you take some other 2 points, they could have some other phase difference. So when these waves reach, maybe the crest of Pandu has reached, but the trough of Andu has reached. Crest of Pandu has reached, trough of Andu has reached, there is a phase difference. Crest and crest have reached, then there is no phase difference. Is that making sense? Thank you, Kanish. Okay. Is that clear? Is that clear? Understoodo? Understoodo? Okay. So when two sources reach a point and these two sources are in line, this is that path difference that Andu's missing that by this path difference. You can see they will not reach simultaneously, and that path difference happens to be d sine theta. Keep this in mind. What is the path difference? D sine theta. What is d? The distance between the two sources. What is theta? The angle at which the rays go and meet. Theta is the angular position. Keep this in mind. Everybody has written it down. Don't worry, it will be there in the notes as well. Next, based on this, you have two different types of interferences, constructive and destructive. Constructive, destructive. Meaning. Think like this. You create a crest. Other person also creates the crest. Both the crests reach simultaneously, they create a bigger crest. When you create a trough, the other source is creating a trough. The troughs meet, create a bigger trough. Crest gives bigger crest, trough gives bigger trough. That's constructive. When you create crest, the other person creates a trough. That's destructive. They cancel each other. And when you have interference happening, these are the two extreme conditions for interference. That's constructive interference, and the other one is destructive interference. So what's the formula in general when two waves add on to each other? Then the resultant amplitude of two waves interfering with each other is given by A is equal to root of vector addition formula, a1 square plus a2 square plus 2a1 a2 cos phi. What is phi? Phi is your phase difference. But there is a formula for phase difference. What is the formula for phase difference? It is 2 pi into delta x divided by lambda. It makes sense. If 2 points are, what is this delta x? Path difference. If 2 points have a difference of one wavelength means lambda by lambda cancels 1, you will get 2 pi. Correct. I just told you, if delta x is lambda, then the phase difference is 2 pi. That's how you can remember this formula. Is that clear? So if you know that the two waves are not reaching simultaneously, there is some difference, then from that length difference you can find the phase difference. From phase difference you can find the amplitude. Also remember that the intensity, this is one formula, intensity is always proportional to the square of the amplitude, and that's why you get intensity formula also. And the resultant intensity is given by, what's the formula for intensity? The resultant intensity is I1 plus I2 plus 2 root I1 I2 cos phi. That's the answer. A root of only I1 I2 cos phi is outside the root. Be careful. For constructive, what is the phase difference? Yes, for will the formation of dark fringe take place in destructive and bright for constructively? Yes. Yes, correct, Rahul Krishna. Very true. Okay, so basically when you have constructive interference, the phase difference between them, del phi, is 0 or 2 pi or 4 pi, like that. Okay, basically it is some even pi. When it is destructive, then the phase difference is pi, 3 pi, or basically some odd pi. Keep this in mind. Yep. It's not n pi, it is 2n pi. Be careful here. It's 2n. 2n is an even number. N pi can be even or odd. So it is 2n pi here, and it is odd pi, or 2n plus 1 pi over here. Be careful. Okay, great, amazing. All right, great. Let's move ahead to the next question. Oh, we have quizzes coming in, but I'm so sorry guys, I could not get up the week quiz up and running, but we'll get it up and running next time. And here comes the quiz on your screen now. Two sources of waves are called coherent. Come on guys, everybody should be able to answer this. Come on, let's see if you can get this question right. Two sources of waves are called coherent. What is the answer? The quiz is here, Pariti. I could not get the quiz up and running because there was some shuffling in the quizzes. Okay, don't worry, by next time I'll get it up and running properly. All right, Kamle is saying C. Okay, looks like Wazim sir is also in the chat box. Hello Wazim sir. Wazim sir is going to take his awesome class of 0 to superhero series tonight, so don't miss it guys. It's going to be super duper fun. You guys were always waiting for it. Okay, good evening Malakpalli, Uma. Okay, everybody saying C? Yup, very good. Same wavelength and constant phase difference. It makes sense, I'll tell you why. Because imagine this, when you have two waves, okay, of same wavelength and same phase difference, then only it will be coherent. But imagine some other wave of a different wavelength Obviously, sometimes the crest is meeting, sometimes crest is meeting the trough. There is no sync. So the wavelength should be same and the phase difference should be constant. They should maintain. Else, imagine some other wave like this. First it is of the same wavelength, then it becomes small, then it becomes big. Obviously, sometimes the crests are matching, sometimes it's not, sometimes it is matching. So here phase difference is not constant. Phi is not constant. Here wavelength is not same. So that's why the blue ones are not coherent, but the yellow ones are coherent with each other. Amazing. Go. Let's move on to the next question. When you see interference of light, then energy is created in the region of maximum intensity. Energy is destroyed in the region of maximum intensity. Conservation of energy holds good and energy gets redistributed, or conservation of energy does not hold good. Come on, guys. Okay. So, Rahul, what you need to do is solve simple questions, solve substitution questions, solve questions without looking at the formula. Try to use tricks, mnemonics and other shortcuts, and try to vary the different parameters by substituting values in that formula. Get a feel, keep revising it over the weeks. Within few weeks you will remember it. It's not about solving difficult problems. B, C, A, everybody is getting confused. This is looking like a good question. Looks like many of you are confused out there, and the correct answer is option C. Oh, by the way, guys, those of you who were wondering what to do, sir, the quiz didn't work, let me tell you, you can still give the quiz, okay, later on, after the class is over. All the questions are available in the quiz format. So if you're watching a replay, maybe you can try out the quiz. I'll just play the quiz later on, and you can answer all the questions even after the class is over. Okay, the conservation of energy holds true because what happens is, when you have two sources S1, S2, and at some place, let's say there is constructive interference, then at some other place you will have destructive interference. So if here the energy was some E, here also there is some E, these energies will add here, but destructive you do not see anything, there is no amplitude over there, so here the energy is zero. You will be like, sir, at destructive the energy gets destroyed. No, the energy does not get destroyed, the energy is shifted to the constructive interferences besides it. So there would be some constructive interference around it, so the energy gets redistributed to the constructive interference places. Total energy is always conserved. So the total energy is conserved, it just gets moved to the constructive places. Hence answer is C. Understood, got it, very good answer, very good. Yep, it is not A. It is not A. Energy is not created, energy is not destroyed. It is a violation of the principle of conservation of energy. Okay, so Anjana Priya, after this class, bacha, refer H.C. Verma theory and short answers. Number 2, refer to NCERT. More than enough. And rest, follow some problem solving book if you have Tattva, or you have crash course material. If you have the crash course notes, more than enough. The crash course notes plus the material plus the assignments and the all the problem solving material you get is more than enough to conquer JEE and NEET. Moving on to the next question coming up on your screen. All right, thank you Madhumita, thank you Ansab for changing your display pictures. I can see many of you are changing your display pictures in the support and showing your love to the channel and all the teachers out here. Thank you very much, guys. Light waves producing interference have their amplitudes 3:2. The intensity ratio of maximum to minimum of the interference fringes is how much? Let's see. Difference between amplitude and intensity. Okay, Sarvesh, amplitude and intensity are related. How? I just told you. Intensity is square proportional. Number 2, amplitude is the extent of that wave, the maximum extent of that wave which it vibrates. So I'm going here and there, I'm going here and there. This distance, 3 centimeters here, 3 centimeters here, that is amplitude. Intensity is how much energy is being given per unit time, per unit area. So energy which is falling on a surface per unit time, per unit area is intensity. Obviously, if your amplitude is more, your intensity will be higher. they are related, but they are two different physical quantities. Is that clear, bacha? Okay, very good. So guys, the answer is option C. Oops. Looks like Mohammad Rizwan was correct, Darshini was correct, Hanush was also correct. Many of you got it wrong. Okay, so I'll tell you how to solve the question. See, maximum intensity is when you have constructive interference. So that time the maximum amplitude will be just A1 plus A2. A1 plus A2. What is the amplitude's ratio? 3:2. So it will be basically 3 plus 2. Doesn't matter. We just have to find the ratio. So basically it is 5. Then if you talk about the minimum amplitude, that will happen during destructive interference. So what is the minimum amplitude? A1 minus A2, whichever is bigger, you take it first. So 3 minus 2, which is 1. Now all you need to do is figure out what is maximum intensity upon the minimum intensity. I just told you intensity is proportional to the square of the amplitude. So I by I will be amplitude max by amplitude min, but the square of it, square proportional. So this will become nothing but 5 by 1 square, which is 25:1. So is that option there? Yes, it is there. Understood? It's not B, guys, it's C. Okay, is it clear? Got your doubts resolved? Is this session helping you? Am I clearing your concepts with basic questions? Tomorrow's session will be with little bit tougher questions. Okay, today I want you to grasp the concept. I want you to understand the concept. I want you to get that confidence in the lecture and the topic. Moving on to YDSC. Very good, MV. Thank you, Jeremiah. Thank you, Madhumita. Great, Dajan. Thank you so much. So moving on to YDSC, Young's double slit experiment. This is the most important topic of this class because this topic comes very regularly in almost all the exams. In this setup, it demonstrates that light can interfere, and it is seen that whenever you have two sources of light and they merge, they interfere on some screen, you will see a pattern. Looking at the pattern, one can figure out that yes, light has interfered. You can find out different aspects about the light, including its wavelength. And by changing the arrangement, you can change the pattern on the screen in different ways. Starting with, you have a source. That source will create some light. So you need a single slit. Why do you need a single slit? I'll come to that later on in diffraction. Let's not worry about the single slit aspect now. But this is very important. You need two slits. Why do you need two slits? Why you can't put two sources? Answer it in the chat box. Let's see how many of you can get this. So you need these two slits, and from these two slits you will see those waves getting created, and those waves fall on a screen and you get a fringe pattern. Fringe meaning bands. You get bands, bright band, dark band, bright band, dark band. It tells you some places there is constructive, some places there is darkness. That means it is destructive in nature. So this whole setup is called as a YDSE, Young's double slit experiment setup. It has to be performed with a double slit, not with two sources. Why do you think it is needed? Hello Madesh Mohan, welcome aboard. Because they spread for interference. Won't two light bulbs also interfere with each other? Obviously they will interfere, but you will never ever get a band. You will never get that interference. Reason, I just told you some time back. Is this coherent or is this non-coherent? Is this coherent or is this non-coherent? I told you it is non-coherent. So if this is non-coherent, it's not in sync. I don't know when this bulb is creating a crest, maybe this bulb is creating a trough. Next time when this is creating a crest, this is creating a crest. So there is no sync, there is no relation. So I cannot figure out what kind of interference will happen there. But if it is a derived source, and I know that these two sources create their crests and troughs simultaneously, I know that yes, if this creates crest, and they reach here at this time, I know after some time also the same thing is going to happen. You will get some consistency. Yep, that's why it's coherence which matters. Very good, bacha log. Some of you gave the correct answer. Yes, for the same phase. It's not about monochromatic. Even if you use white light, it's okay. Even if you use bichromatic or trichromatic light, it is okay. You will still get interference, but yes, you will get different colors. The reason why you get interference is because of coherence, not because of anything else, not because of monochromatic light. Monochromatic light will give you single color interference pattern. When you use bi means two chromatic wavelength, then you have blue pattern and orange pattern or green pattern with yellow pattern. That's what it is. Okay, so let's move ahead and let's have a look at how the interference pattern looks like. You can see these are the two sources separated by distance small d, and if you go at different points, you get different interferences, constructive, destructive, and so on and so forth. This is a bright fringe, this is a dark fringe, this is a bright fringe. You get alternate bright and dark fringes. One thing is common though, whenever from these slits you reach the center, that's over here, you always will get a bright fringe, irrespective of which color you use. Reason, because these two waves will always reach together at the center. If two waves reach together, they will be in sync. There is no path difference, there is no phase difference. They will have to interfere constructively. But if you go at some other place, one crest might be reaching, the second's trough might be reaching. That's why you are getting a dark fringe over here. Is that clear, everyone? Yep. Also, yes, monochromatic has only one wavelength, correct. What's the difference between coherent and incoherence? Prasant, go back into the session. At the start I've explained it. It's somewhere in the beginning. You can probably ask somebody else or watch the replay, or even in the live class you can go behind, watch the complete theory of coherent and incoherent. Okay, how many fringes are formed? No, it's not infinite, it is finite in nature. Although you might think, how can it be finite, sir? The answer is, see, when you are here in this small range of angle, the fringes are almost equal, but as you go away and away, the fringe width increases, and after some time it increases so much that you will have to travel infinite distance to get the next fringe. So there is a limit of the fringes, it cannot be infinity. Keep that in mind. Okay. Also, this is called as the fringe width, the width of one dark to next dark or one bright to next bright. Okay, this is a fringe width or this is a fringe width. Dark to dark or bright to bright. Dark to dark or bright to bright. That's a fringe width. Keep this in mind. Next thing, if you change the color, the fringe width changes. If you change the color, if you change the wavelength, the width, the positions change. You can see that when you use blue, when you use green, you will not get the maximas, minimas at the same place. So all these things are very important. So let me give you some important formulas right over here. Starting with, if this is the small d, the distance between the slits, if this is capital D, distance between the slits and the screen, okay, and one dark to the next dark, one dark to the next dark, or from one bright to the next bright, this is called as the fringe width, beta. And where is your central fringe? The central fringe is somewhere here. Yes, I think the naming has gone slightly haphazard, guys. This is supposed to be bright and this is supposed to be dark. Okay, I'm going to shift it later on, don't worry about it. But yes, this is your central fringe right over there. And the fringe width formula is lambda d by d. This is very important formula. Next thing which is important, which I have already given you, but still, if you reach at any point, over here, and let's say from the central line, okay, that angle which is there, is theta. Okay, so that angle, oops, sorry guys, one second. This angle is theta. I'm just putting it a little bit darker over here so that you guys can see it. Then this theta, what is this theta called? This is called as the angular position. Usually this distance is much larger than the distance between the slits. So D is much larger than small d. Keep this in mind. This is very huge. the distance from the screen to the slits. Slits are very close by. This is highly exaggerated diagram. Also, the angular position can be found out using this formula. Remember this, tan theta, opposite by adjacent. If this is called as y, the y coordinate with respect to the central position, adjacent, it will be y by d, but when theta is small, which is usually the case, tan theta is always theta approximately, so it will be equal to y by d. This is also a very important formula. Yep, very good, very good. Oh, I should change the color of the pen. Oh, is it? Okay. I think I need to change the color somewhere, maybe. I don't know. Should I change it over here? Okay, now is it seen, guys? Now is it seen? This is y, guys, and this is theta. I hope I have not made it worse and it is good. Okay, or maybe I need to make it a little bit dark. I don't know. Okay, but okay, I'll just put it over here in all the colors. Hopefully one of the color is seen. Okay. Sir, what is y? Okay, y is the coordinate of the point where you are measuring the interference. So this is the point. This is the point where you are measuring the interference. Y is the coordinate. Y coordinate with respect to the central. With respect to the central fringe. So that's why tan theta is opposite, which is y, divided by adjacent, which is the base. Is that clear? Okay. I hope this is clear. Amazing. Okay. Yes, Ramya, I'll be doing it soon. Okay. Amazing. Let's move on to the next few questions. But before that, guys, what happens if you get really fed up? What happens if you get really fed up in life and you're like, sir, I cannot take this Young's double slit anymore. I'm going to take this setup and I'm going to throw it in the ocean. I'm going to throw it in the water, sir. If you throw this Young's double slit experimental setup in water, what will happen here? What will happen here? Come on, guys. Okay, monochromatic properties means it will just have one single wavelength, no other colors, unique color. That's it. Okay, so guys, come on, think about it. When the moment you put it in water, what will happen? Yep, the refractive index changes. If refractive index changes, wavelength changes. Speed of light decreases. Speed of light decreases. Speed of light decreases. Wavelength decreases. Wavelength decreases. In this formula, beta also decreases. If beta decreases, then this pattern will shrink. It will shrink in water. It will shrink in water. No Doppler effect, bacha. Divide by mu. Correcto. Correcto. Very good. Yes. This is 0 to superhero Gokul Gaming. This is different. Okay, time for some quizzes coming up on your screen now. A screen is at 2 meters distance from slits, illuminated with light of 600 nanometers. Fifth maxima lies at 0.005 meters from central maxima. Then what is this small d? Come on. Kalani thought it will sing. Yes, it will sing, but while sinking also, it will do its job. That's what physics is. Okay, so come on guys, which formula are you going to use? You need to find small d. You know the fifth maxima. So basically this is your screen, this is your theta, this is where your fifth maxima is, this is your central fringe, interestingo, and yep. So what's the y coordinate? Think about it. The y coordinate, fifth, where is it? It's given, right? Fifth maxima. So basically there are 5 fringes. So in this y there are 5 betas. 5 betas are there over here because it's the fifth fringe. Bright to bright, bright to bright, 5 fringes. And beta is nothing but lambda d by small d. Hence, small d is equal to, bring d here, put y there, 5 lambda capital D by y. Now I know everything over here. Let's start filling it up. Lambda, lambda, lambda. Where is it? It is 600 nano. Nano. What is the value of nano? 10 to the power minus 9. D. What is D? 2. So put 2. divided by, what is it? 0.005. 0.005 means, okay, I'll just put 0.005. This 5 and this 5 goes, and this will become 6 2s are 12, and 2 zeros and 10 to the power minus 9 will become 10 to the power minus 7, and this will become 10 to the power minus 3. One of the 5s has already gone, so this will become 12 into 10 to the power minus 4. Just check this out. 12 into 10 to the power minus 4. Yes, I can write it like this, but this is in meters. So this is 1.2 into 10 to the power minus 3 meters. 10 to the power minus 3 is milli. So 1.2 millimeter. Is that there? Is it there? Yep. Look at you guys. Very good, Ansab. Very good. 11th, 12th, movie students also can watch Saja. Hi, Namalai. Very good music. Very good. Excellent, Darshini. Excellent, MV. Excellent, Prashant. Sonalika. Very good. Excellent, Motu. Okay. Very good. Let's move on. Move on to next question. A double slit experiment is illuminated by light of this much wavelength. Slits are this much apart. Screen is 1 meter away. Angular position of the 20th maxima. Theta they have asked. What is angular position of the 20th maxima? So come on, 20th maxima. This is your central fringe. This is your central fringe. This is your theta. This is your D. Come on guys, you should be able to do this. What will be theta? Theta is roughly tan theta because it is small, and tan theta is opposite by adjacent. So it is y by d, and y, because it is 20th maxima, there are 20 fringes here, so it will be 20 times of beta. So d comes below. What is fringe width? It is lambda d by small d. This d comes over here but gets cancelled. So 20 into wavelength, which is 6000 Armstrong, which is 10 to the power minus 10, divided by small d. Small d is 0.1 centimeter. So 0.1 centimeter is 0.1 into 10 to the power minus 2 meters. Okay, fair enough. Now do the math. 2 6 are 12. Count the zeros. 1 2 3 4. These 4 zeros with 10 to the power minus 10 will become 10 to the power minus 6, and this will make it 10 to the power minus 3. So you will have 12 into 10 to the power minus 3, I suppose, which is option A. Correcto. Yes, it is. It is. It is. Very good, Prashant. Very good, Joshua. Excellento. Hi, Shreyas Rajmohan. Nice to see you. High five. I am so glad Gokul Gaming. That is my whole motive. And yes, do not forget to smash the like and the subscribe button. If you are not yet subscribed, please do that. Oh my god. Okay, let's move on to the next one. Wow, we have already reached diffraction. Isn't it fun? Guys, trust me, you stay with me. We'll do all the topics. Tuck, 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 tuck. We'll solve problems also. Next classes we'll do more problems. Within no time, your entire physics portion will be done and you will get very good marks. That's my guarantee. You watch all my classes, that's all I'm asking. What is diffraction now? You can see over here what's happening. There is a source. It's creating disturbance. But the moment it comes out, it's spreading. That spreading through a corner or through a slit is called as diffraction. Now, imagine guys, just imagine this. There is a pandu and there is a wall and there is a door here. Okay, so basically this is a wall and this is a door. You open the door. Okay, you just open this door. And this pandu is going to throw tomatoes. What is he going to do? He's going to throw tomatoes in all the directions. He's very angry. His mom didn't give him time. And she told that you should not play video games, you should study. So Pandu is very angry. What he does is, he takes all the tomatoes in the house and starts throwing everywhere like a mad person. There is a door also. And there is another wall behind it. There is going to be another wall behind it. guess what the wall will become? This wall will paint it red. Yep, only in this part. There will be a splash of tomato here, correct? Just behind the door. But this part, nothing. This part, nothing. It's not going to be like a Rajnikant movie where the bullet goes, it bends and goes like that and hits somewhere here and this will become red. Will that happen, guys, in real life? Only Rajnikant can do it. Nobody else. Only Thalaiva can do it. Nobody else can throw that tomato, bend it and make it hit somewhere. Correct, guys? But waves are like Rajnikant. Who are waves? Waves are like Rajnikant. What happens? Waves bend. They can go anywhere. Look at this. This is Rajnikant only, guys. Nothing else, obviously. If the tomatoes were like waves, the waves will spread and you will see a beautiful pattern of tomatoes on the wall. If tomatoes were sorry guys, not Rajnikant, my bad, waves, then on the wall you are going to see a pattern. You will see a splash here, you will also see a splash here, you will also see a splash here. Dark, bright, dark, bright, dark, bright pattern, interference pattern. Understood? Sonalika is missing Andu and beautiful Champa. Okay, don't worry. Now they are romancizing. Okay, they have met already. Okay, so let's not bother them. Let's talk about Rajnikant. Okay, so beautiful pattern coming out here. This is an interference pattern which will be created by diffraction, and this is called as a single slit diffraction. Meaning you have a slit, single slit. The light spreads instead of just going in a straight line. That is called as a, you can see even small spread happening here. There is a slit here. You squeeze it, it's spreading right over there. And there is a beautiful formula for that. So I'll just put up all the details right over here. So this is your, this is your slit, and the width is, let's say, A, okay, and let's say here you have a screen, and on the screen you are going to, you're going to have a maxima, you're going to have a bright region. This is your central maxima, and you will also have more maximas on the sides. You will also have more maximas on the side. These are all maximas. You will also have dark regions in between, like you can see over here. These are your dark regions, or basically your minimas, and the angular position of any minima is given by A sine theta is equal to n lambda. N is any integer. This is only for minimas. This is for whom? Minimas. For maximas, the formula is slightly different. For maxima, A sine theta will be equal to, instead of n, it will be odd number by 2 lambda. That is the change in the formula. That's all. Yes, is this for 2022? Yes, it is. Are you PBC or PMC? I am PCB. I am PCM. I am PMC. I am Shreyas Prashant. Yeah, I'm Shreyas. I'm Captain Shreyas. Okay, is that clear? Shall we go ahead? Can you draw the graph for YDSE and single slit? Yes, Puzugar. This is a very interesting graph. If you compare the intensities, this is intensity versus the distance on the screen. It is very interesting to note that for Young's double slit experiment, the graph comes out to be uniform. It is like this. Okay, it goes like this. This is for YDSE. For Young's double slit experiment, all the maximas are at the same level. But, what is that but? The but is for single slit. For single slit, the graph will be like this. That's it. It dies out. It dies out. This is for single slit. For single slit. Okay, keep this in mind. So the intensity is to die out very soon. You won't see too many maximas. What is the meaning of a slit? How do I tell? Okay, you take a cardboard and you cut that cardboard in between. Like this is your cardboard, take a blade and cut it in between. So there is one small thin gap, that is a slit. Is that okay, bacha? Okay, Srishti? That's the meaning of a slit. I hope this is clear. Can we go ahead to the next one? Yep, all right, all right. Oh, we have some quizzes now coming up on your screen, and here it comes. Yep, there you go, there you go. Okay, come on guys. A single slit diffraction pattern is obtained using a beam of light. What happens if red light is replaced with blue light? Come on guys, this should be easy to answer. What will happen? What will happen if you replace the red light with blue light in the diffraction pattern? Come on, you should be able to do this. Okay, Pushugaru saying option B. Pushaharsu, sorry. Pugazu. How do you pronounce your name, man? Pugazaharsu. I guess that's what it is. Slit acts like a source. Yes, it acts like a secondary source. Correct. Producing cylindrical wavefronts. Okay, so guys, the correct answer for this question is option B. Diffraction fringes become narrower, because if you look at the formula, it is A sine theta is equal to n lambda. If you are using a single slit experiment and red light is replaced by blue light, blue has shorter wavelength, so lambda will reduce. If lambda reduces, theta will reduce. Theta reduces, all the fringes will come close. For any n, the theta will reduce. So the first bright fringe will come here, the second bright fringe will also come closer. It will reduce. Correct. That's why it becomes narrower and it will become crowded, like the one shown over here. Yeah, all these thetas will come closer. Keep this in mind. Okay, moving on to the next question. A slit of width A is illuminated with white light. White is made of all the colors. The first minimum for red. So out of the white, one of the color you are picking, and that's red, whose wavelength is also given. Then it will fall at 30 degrees. Then A will be how much? Then A will be how much? Come on, my warriors, figure this out. It's an easy one. Use the formula. I want all these formulas to be in your head. Don't try to go back, try to recollect it. After today's class, you will never ever say, sir, wave optics is difficult. Come on, let's try this out. So the formula that we are going to use is A sine theta is equal to n lambda for minimum. This is for minimum. For minimas. For maxima, it is odd by 2. Okay, so what is A? A is what we need to find. Sine of 30, theta is 30. N, first minima, n is 1. Wavelength 6000 Armstrong, meaning 10 to the power minus 10. Therefore, A, sine 30 is half. So into half is equal to 6 into 10 to the power minus 7. 6 2s are 12. So basically it will be 12 into 10 to the power minus 7. So do we have it? Yes, we have it. Option B. Very good, Darshini. Very good, Diljan, Gopika, Jana. Guys, got it. Very good. Very good. Very good. Like how they show in movies and films, right? They show the same scene 3 times. Yeah. So, and then it comes Balaji Telefilms. Very good. Okay. So now what are we doing? Are we on a highway? Oh, yes. And what is this? Oh my God, there is a car coming. Oh, yes, it's a car. Okay. It looked like a bike. It looked like a bike. And then suddenly when it came closer, you realize, oh my God, this is a car. So has it happened to you? Has it happened to you before? Like you see something very far and you're not able to make out whether it's a truck, it's a car, it's a bike. And then when it comes closer, you realize that there are 2 headlights, it's not one. So why is this happening? This is because of diffraction. Like, sir, diffraction, how? I didn't get it. Okay, so basically I'll tell you what. Your eye is also a hole. I know, you guys are bio students, you all know it, obviously. How is the eye made? And you will also give me gyan now. Sir, eye is made of this part. Sir, eye has this, sir, eye has that, sir. Very good. Okay, I don't know much about the eye, okay? But I know some basic things which is required for physics. Eye has a hole So that is how a physics teacher explains an eye as a whole. Okay, please don't tell all these things to your bio teacher. I will be chucked out. Okay, so guys, that hole is going to act like a slit. When light enters your eye, the light will spread. And when you have two sources of light, source 1, source 2, source 1, source 2, this source will enter the eye, it will spread, it will create an image. This source, light, will also enter the eye and it will create an image. Where? Retina. See, I know that part. Amazing, guys. So what happens if both the images are formed very close to each other on the retina? If they are formed on the very close to each other, then you will see it merged and your brain will be like, hey, it's one light, man, it's one light. Yeah, it's one light. And then when it comes close by and let's say the images are formed at two different places, there is no interference and you see two lights, then your brain will be like, hey, come on, man, that's two lights out there. Yes. So that is called as resolution. That is called as resolving. Look at this beautiful animation to explain you. So if the images are formed at two different places, then you can see them very clearly. But if they are formed such that they are very close to each other, because light will spread, remember, it will not form a point image, the light spreads because of diffraction, which is spreading of light. So when the light spreads, it should not overlap onto each other on the retina. Yes. Oh my God. MV, don't worry. Our brains are automatic for understanding all these things. It's all involuntary. It's not voluntary. It's not like you can tell the brain, chill, man, stop analyzing that light. Let's take a nap. No, the brain will still work. It will still give you the image. That's the beauty of your brain. It works only in certain things, not during the exam. Okay, thank you, Srishti, so much. So, guys, when you are seeing, imagine Pandu is using telescope. Pandu is in the boys' hostel. Champa is in the girls' hostel. Obviously, Champa will be in the girls' hostel only. No, okay. Pandu is using what? Microscope? No, telescope. He's watching Champa, man, not microscope. He's not watching microorganism. He's watching Champa. He's using telescope. And then there is Champa also. And there is another beautiful girl. I don't know, maybe Katrina. Okay. Champa and Katrina are together. Girls' hostel. And if they are standing very close by, he should be able to see them distinctly. If Pandu sees Champa and Katrina like this, he'll be like, what is this? What has happened to this girl? Right? He should be able to see the two girls like this. Pandu is very naughty, I know. He should be able to see Champa and Katrina like this. Resolved, clear. If it is just resolved, it is fine. He is able to see Champa and Katrina separately, just separately. He's not seeing a merged image. He's not seeing a mutated Champa with Katrina. This is mutation. Some weird looking figure he will see. Both Katrina and Champa. Maybe very beautiful, maybe very bad. I don't know. Okay, very good. So, that is with telescope. Same thing will happen with microscope. Pandu starts, he sees that nothing is happening in life. I should not watch humans anymore. I should watch microorganisms. Even if he sees microorganisms using his microscope, he can see two microorganisms, two amoebas with each other, close to each other. Either their images can be merged or they can be resolved. You should see at least like this. For clarity, at least this much, if not this, at least this much. And the distance between Champa and Katrina, where their images are formed distinctly. The distance between Champa is in the girls' hostel, Katrina is in the girls' hostel. The distance between them so that you can see them clearly is called as the limit. What is it called? Limit of resolution. What is it called? Limit of resolution. And its inverse, 1 by that, is called as resolution power. resolution power. Imagine Champa and Katrina can stand very close to each other. They can be like, oh, come on, let's take selfie. And they're taking selfie, they're standing very close. Their limit of resolution. So if the distances are very close and still you can see them, they're standing close to each other, they're taking some girls BFF hashtag selfie, and still you can see them, the limit of resolution has gone down, the inverse will become high, their power will become high. Pandu through his telescope can see Champa and Katrina taking a selfie. He can see Champa and Katrina taking a selfie. They are close, still he can see them. Understood, guys? Understood, clear? Why intensity reduces in diffraction? That's because of the manner in which the mathematics work. There are number of sources which are formed in a slit, and the way the interference happens, the mathematics makes the intensity go down, not the distance. It's not because you are far away, that's why intensity reduces. It's because of the manner, the phase differences in that single slit which create the reduction in intensity. And there are beautiful formulas to remember. Come on, let's go ahead. Resolving power of a telescope. If you are using a telescope, what's the resolving power? D by 1.22 lambda. Come on, put it in your head. Put it in your head. Come on, guys. Yep. Okay. And if it is a microscope, very similar. Resolving power will be 2n sine theta. Instead of D, it is 2n sine theta. And here you have lambda. That's all. Keep this in mind. Definitely, Sonalika, you will meet them one day for sure. Okay. Very good. Avnandhani Sivakumar, very good. All right, thank you, Srishti. All right, Prasant, MV, everybody having fun? Look, oh my God, you guys are full of laughter. Oh my God, I didn't see the chats. Now I'm seeing it. Great, great, great. So let's solve some questions coming up on your screen now. In an observation with telescopes, Pandu is observing, having aperture of lens D, the wavelength of the light is tripled, then the resolving power will 3 times, no change, can't say. Come on, guys. Hi, Himabindu. Hi, Sriji. Oh, my blessings are always with you, bacha. Don't worry. Can we go ahead? Yep. Let's see. B, 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 C. Oh, somebody saying C, somebody saying B. Come on, guys. Decide what it is. Let's go back. Let's go back. This is the power of a telescope. D by 1.22 lambda. Lambda is there below, power is there on the top. Then the resolving power, guys, I just showed you the formula. The resolving power, why did I say R? If I've written 2 R's, let me write RRR. I've not watched it, guys. I heard it's amazing. I'll watch it later on. Sorry. It was supposed to be resolving power. Okay. Is inversely proportional to lambda. So if the wavelength is tripled, lambda is made 3 times, then the resolving power will have to be made 1 by 3 times. Inverse, right? Inverse, right? Okay, very good. So decreased by 3 times. Perfecto. Amazingo. Moving on to the next question coming up on your screen. 2 points separated by a distance of 0.1 millimeter can just be resolved in a microscope. Okay, you're watching microorganisms. Okay. When a light of wavelength 6000 is used, okay, if the light's wavelength is changed to 4800, then the new limit will become, come on, guys, figure this out. Okay, somebody saying A, somebody saying B, figure this out, okay, the limit is inversely proportional to resolving power, and resolving power is inversely proportional to wavelength. So limit is proportional to wavelength. So limit 1 by limit 2 is wavelength 1 by wavelength 2. Limit 1 is 0.1 millimeter divided by limit 2, I don't know. Wavelength 1 is 6000 Armstrong, and second time the wavelength is 4800 Armstrong. Things get cancelled, like 0, 0, 0, 0 gone. 60 goes, 48 goes with 12. So this will be 4 times, this will be 5 times. So L2 will become 4 by 5 into 0.1 millimeter. 4 by 5 is 0.8. So 0.8 into 0.1 is 0.08 millimeter. Oh no, sorry, millimeter. Excellent, guys. You guys are absolutely correct. What is Lloyd's mirror, Anu? I will tell you probably tomorrow when we do a problem. Lloyd's mirror is a construction where the one of the light rays which is falling on the mirror changes its phase difference, because of which wherever you are expecting constructive interference you get destructive, and where you are expecting destructive you get constructive. So you solve the problem for the exact opposite. That's what a Lloyd setup does. Okay. Wow, we have reached the end of this class, and that is polarization. Excellent. Okay, polarization. What is polarization, guys? See, when you have a transverse wave, the particles, the field or whatever is being propagated, that varies perpendicular to the direction of propagation. Like in the case of light waves, it is the electric field that goes up, down, left, right, in, out, and the rays are going perpendicular to the direction of propagation. That direction in which the particular electric field oscillates is called as the plane of polarization. So right now the electric field of light is varying in the YZ plane. It's varying in the YZ plane. That is your plane of polarization, and this is the direction in which it has been polarized. So if you see from the back, you are just going to see it go like this, up and down, up and down. So this is the direction of polarization. Cool. And sometimes the light is not polarized. In fact, the light that you see in day-to-day life is not polarized. There are oscillations like this, oscillations like this, oscillations like this, oscillations like this everywhere. That is called as unpolarized light. That is called as unpolarized light. So ordinary light, sunlight, tube light, okay, all the lights usually are polarized. Only in certain situations it is polarized, meaning you are limiting the vibrations in a specific direction, and that is called as a plane of polarization in which it is vibrating, or you can also refer to it as the direction of vibrations or the direction of the polarization. Great. Now, when you pass unpolarized light through something called as a Polaroid or a polarizer, the unpolarized light gets polarized. I'll repeat. When unpolarized, meaning the vibrations are there in all the possible planes, that light passes through a polarizer. These are some crystals or some liquids, organic compounds, and when the light passes through it, then it limits, it restricts all the other vibrations. It only allows vibrations in one direction, and whatever you get out is a polarized light. That is called as polarizing. That is called as a polarizing effects, and that happens through polarizers or polarides or polaroids. Okay, so this is a beautiful diagram to explain all of this. Observe this light. Do you see the vibrations in all the directions? It's like one dhamaka. It's like everywhere there are vibrations. So when the vibrations are there in all the planes, what do you call it? Unpolarized light. It is called as unpolarized light. When unpolarized light passes through the polarizer, then it becomes polarized. That polarizer has something called as transmission axis. That means it transmits every vibration only along that line. So out of all these vibrations, only this vibration comes here. This all gets cut out, blocked. It gets blocked. Yes, do we need to study formula and the main concept? In fact, the reverse Janaram concept and the formula. Okay, so if this intensity is I naught, what comes here is exactly I naught by 2. Okay, ignore this, guys. Ignore this. Okay, not needed. Okay, if this is I naught, exactly half the light comes over here. Very, very important. Now, the next point is when this polarized light passes through another polarizer, it is quite possible that this direction and the transmission axis might make some angle with each other. I'll repeat, the light got polarized, there is some plane in which it is vibrating, but it is very much likely that the next polarizer could be having an angle which is different from the plane of vibration. In that case, a component of it goes here. So here, if this intensity, I call it as, let's say, I, then whatever comes out over here is I cos square theta. Ignore this. It is I cos square theta, the cos square. Why does this happen? Actually, if the amplitude here is A, then the amplitude that comes over here is A cos theta, because intensity is square proportional. That's why you get the square term. What is this law called? This is called as Malus law. Do you see this? Guys, this is not Malus law. This is not from Kerala. Some people ask me, sir, is this coming from Kerala, sir? No, sir. No, boys. No, guys. This is not coming from Kerala. This is something else. Okay, this is the name of the guy. So it is Malus law. Keep this in mind. Okay, very, very important. Excellent. Excellent. Oh my God, looks like Wazim sir is spamming. Don't listen to Wazim sir, guys. Wazim sir is trying to distract you. He is trying to test you. Okay, great. All right, let's get going to the next part. And the next part is Brewster's law. What is this? Brewster's law. Brewster's law tells you how the light which is refracted and reflected can get polarized when the medium changes. I'll tell you with a simple ray diagram. Look at this light. This light has vibrations in all the directions. This light may be coming from the sun, may be coming from some other street light. It is unpolarized. It has vibrations in all the directions. This light maybe falls on water, or maybe falls on glass, or some different translucent medium. We all know that the light, when it falls, partially it gets refracted, it bends, the one which travels into the other medium, and partially gets reflected. Refracted, reflected. Now, this unpolarized light becomes polarized only under one situation. Only under one situation. And that happens when this happens. The reflected light and the refracted light are perpendicular to each other. This is what Brewster's law is all about. When the reflected light and the refracted light are perpendicular, that's when it happens. Oh, by the way, this is angle of incidence. This is angle of reflection, which is also angle of incidence. Laws of reflection, obviously. And this can happen only when tan of I is equal to mu. This is the condition for that. Mu is the refractive index. Everybody got it? Okay. Understood, clear. Shall we go to some problems? Amazing, go. Guys, Wazim sir will be coming and teaching you at 9:30. Be there. Okay, you will have maybe around 40 minutes for having your dinner. Don't worry, I'm going to give you that time. Okay, I'm not evil. Starting with the question coming up on your screen. And here it is. Two Nicola prism, doesn't matter whether it is Nicola, Bicola, doesn't matter, are inclined to each other at angles of 30 degrees. If I is the intensity of ordinary light, incident on the first prism, then the intensity of light emerging out of the second prism will be, hint, this, don't get confused by the word prism, think of it like polarizer. Think of this diagram. Light is coming from here, goes from first polarizer or prism, whatever you call it, and then goes to the second polarizer or prism, one and the same thing. So then what will happen? Then the intensity of the light which comes out from the second prism is, okay, come on my warriors, let's figure this out. So unpolarized light is entering polarizer 1, then it gets polarized, then it enters polarizer 2, and because this polarizer is at certain other angle, it's clearly mentioned, it is at 30 degree, so it is at an angle, so the final ray is also going to be polarized in some different direction. So if this has an intensity of I, we know unpolarized becomes polarized, so the new intensity will be I by 2. Of course, the final intensity, whose laws? Malus law, guys, sorry. I by 2 into cos square theta. This intensity is cos square theta. So I by 2 cos theta. Theta is 30. That means it will be cos square 30. What is cos of 30, guys? Cos 30 is root 3 by 2. Right? Root 3 by 2 square. Which means this will be 3i, and 2 into 2 into 2 is 8. 3i by 8. That is the answer. Where is 3i by 8? Here. Option D, guys. Option D. Understood? Oh, clear? Oh? Yep. Yes, it is a previous year question answer. It's been asked many times. Yep. Answer D. Very good, Hanush. Very good, Andhani. Motu Patlu. Decide. Your name is an oxymoron. You know what's an oxymoron? Alright. So, let's go to the last question coming up on your screen, and here it is. A beam of light strikes a piece of glass at an angle of incidence 60 degrees. Reflected is plane polarized. Hint, Brewster's law. The refractive index is how much? Okay, already some of you have started answering. Okay, Suman saying option B. What about others? Come on, guys, fight it out. Figure out the last question's answer. Yes, talking in contrast. Okay, so very true, Sriji. Okay, so go back in case you forgot. There it goes. When the reflected light is polarized, that's when you have to use Brewster's law, which is tan I is mu. That's it. Use that over here and you shall get the answer. Tan I is mu. Tan, what is the angle of incidence? 60 is mu. Mu is root 3. That is the answer. Done, done, done. Yup, amazing. Root 3 is the answer. Now, guys, if you had fun today, you have to learn through Crash Course, because the combination of Crash Course with YouTube is fabulous. Students who are in Crash Courses are still watching YouTube. Students who are in YouTube are still taking Crash Courses, because this combination of studies is excellent. Reason why I always tell my students to take up the Crash Course is because you get interactive classes with quizzes, hotspot, class teacher, two-teacher model. Ask any doubt that you have in the class. You have tests which you will have to find otherwise from different places. Sit at home and give this test. You get beautiful report cards for it. Not just that, you get assignments after every class, chapter assignments with many questions which are going to keep you busy, so that you don't have to search and buy different materials and books out there in the market. And you will have JEE Crash Course, link is also there. There is also NEET Crash Course for PCMB. All the 4 subjects, 120 classes, live doubt support, everything that I told you, all India rank test series, and complete recording and support till your final NEET exam, even if it gets postponed. All this for an amazing price of 1,800. That's peanuts, guys. I mean, for the next 3 months, get your full support from Vedantu, even if you are studying in coaching, even if you are studying from by some personal mentor, or even if you are studying by yourself on YouTube. This crash course is going to be revolutionary for you, and that's your Shreyas sir is telling you. So go ahead with it. And if you face any problems, just write me on my Instagram handle Shreyas_Vedantu, or you can also ping me on my WhatsApp number, which has been scrolling for a very long time. Join our Telegram channel to get the PDF, of course. And yes, go ahead, smash the like button and hit the subscribe button. And I hope you guys had an amazing time. No, Selva. That means you need to watch more basic concepts, watch more basics, watch my lectures. It's all there, bacha log. Have you seen it? I don't know how many of you have seen the... Okay, I can probably show it to you right over here. Just see this. All my classes are also there in case you want to find it. Okay, let me just show it to you over here. So when you are on ENLITE, ENLITE channel, so we just go to playlist and you can see all the amazing playlists right over here. These are my previous year's series, obviously. You can also see the 12th standard NEET classes and JEE classes right over here. This is 11th standard classes. You can see all the playlists have been beautifully arranged. Go ahead and watch it so that your basics are very, very clear. Okay, bachalo. Okay, let me just get the chat up on the screen, and yes, thank you guys. Okay, and please recommend the channel to your friends and your colleagues, your relatives in the school, in any other society that you are in. Thank you very much. This was your Captain Shreyas signing off. Hasta la vista, guys. Bye bye.